So there are actually 6 total scenarios for frame of reference problems in this class. There are more complicated ones, but we won't worry about them. First things first, let's say a truck is driving to the right at a certain speed. It doesn't really matter. And then someone in the back of the car, let's call him Jim, throws a ball out the back in the opposite direction. What ends up happening is the truck's velocity and the velocity of the ball end up canceling each other out. And whichever one had a greater velocity, it will look like the ball is moving in that direction. So if the ball had a greater velocity, it will look like it is going backwards. Whereas if the ball had less velocity, you can even try this. If the ball looks like it has less velocity, it won't have the same speed as the truck, but it'll still continue traveling in the direction of the truck. You can do this simply by grabbing a ball, walk or run, toss it back very lightly, and you'll see that the ball will follow you at a slower speed, but it will continue to follow you. Another thing is, let's say a person is throwing a ball forward in the same direction that the truck is traveling. I want you to take a step back and think about it. Anytime a car is moving at 60 miles per hour, every single object inside the truck is also moving at 60 miles per hour. So if you have a ball already moving at 60 miles per hour and you give it the additional energy and throw it forward in the same direction, all you're doing is just adding more velocity to it. Okay? So it was traveling at 60, then you throw it forward, and it's traveling 60 plus whatever speed you threw it at. Okay, that was the first 2 scenarios, and I'm going to show you some videos that further exemplify. Okay?
So what are you so excited about?
Well, it's our turn to try a new type of myth, the physics thought experiment.
Great. Something to get the old gray matter working.
So here's how this one goes. Let's say you're driving along in a car at X miles an hour. You throw something out the back in the opposite direction at the same speed. Does it just fall straight down?
Build an air cannon, fire a soccer ball at 60 miles an hour. We'll do it again inside of a moving vehicle going 60 miles an hour. See if the energies cancel each other out, and we get a vertical drop.
Love it. Let's do it.
With the forward and backward momentum matched as close as they're going to get it, the pressure's on Grant for a perfect release.
I don't know about you guys, but that looked pretty good to me. Let's check the high speed.
It really looked good to the naked eye, but the judge in this case is the high speed.
Oh my God, it's like a cartoon. It's just in the air, it stops, and it just falls.
Look at that.
Fantastic.
I mean, look, it doesn't move at all. It's going straight down.
Dude.
Woo! We did it! We did it! Yeah! Vector edition! Yay! We canceled out velocity!
This one is also very similar to the one I was telling you about earlier, but it gets a little weird if you think about it more broadly, because you can have other scenarios where it's like a boat is traveling in a certain direction to the right, the person is walking to the left, but the boat's speed is still greater. So while the person does look like they are traveling to the right generally, it'll be at a less speed because they're walking backwards. This problem I want to kind of show off in actually a Mario video that I found, because I think it actually does a really good job of this. You can even see it with this lady. She chose the wrong treadmill to walk on at the airport, and she's trying to fight it, and you see her walking, and then right when she stops moving, the treadmill takes over, and she no longer has any velocity in that direction. And then you see the people to the right actually using it correctly. They're traveling at a significantly faster speed than she is because they are walking in line with the treadmill. So I want you to notice how initially you can see Mario's speed is this base level. And then when we continue this video and he goes onto this treadmill going in the same direction as him, he flies forward. He was already traveling at 1 speed, and then he got the additional bonus of that treadmill traveling in the same direction. And then once he jumps onto the other treadmills traveling in the opposite direction, he slows down immensely because he's having to overcome the speed of that treadmill in order to move forward. So you can kind of start seeing how general treadmill-esque problems where you're running on top of something, how velocities, which are vectors, can cancel out, they're going opposite, or add together if they're going in the same direction. So this one is something that really just is done better in an example. If you ever have found yourself driving on a highway and you look over to the other lane traveling in the opposite direction, those cars look like they are moving fast, right? Compared to the cars next to you and even the road in between, any of the barriers in between. That's because they're traveling at 60, you're traveling at 60, so it's almost like they add together, and that's how fast it looks like that object is traveling. The other one is, let's say you're in a car and you want to pass somebody. You're both initially traveling 60, you're perfectly in line with each other. Then all of a sudden you start speeding up, and it'll look like the car next to you is traveling back. So I really want to quickly show you some examples of that I found on the internet. So as you can see in this video, all of these cars that they're passing are passing at a greater speed than the barriers, like right now, and all the light posts. These trucks are traveling at greater speeds, so it looks like they're traveling by his car quicker. However, since you're inside the car, it almost looks like everything else is moving when you know for sure the trees aren't moving. But because of our frame of reference being in motion, that is why it looks like stationary objects move. Okay, so this time I want to show you this video where a car is going to pass another truck. So we have our car here that we will be watching from. You notice how the car obviously signals to be safe. This is a driving instructional video, so that's why it's cheesy. Then this car starts passing the truck. While the truck is moving, obviously, the other car is going just faster so that it looks like instead of the truck going at a certain speed, looks like the car is just going slightly faster. This video is cool because it shows both views. Then you'll see right here, look in the rear view mirror of this car. Obviously the truck isn't moving backwards, but compared to the car driver in this car, it will appear as if the truck is moving backwards right about now. So you'll see truck moving backwards, car moving forwards at greater speed. Here's another video where we see a car obviously moving. Right now, it's not moving anymore. But we switch over to this second clip where we see him passing. And you see the car all of a sudden looks like it's moving backwards in comparison to our car driver. Does that kind of help you visualize it? If not, try it on your own.